Okay, so we're starting book 5.4. We have two different types of numbers to talk about. We have irrational numbers and rational numbers. Irrational numbers are numbers that go on forever and ever. And see these three dots? That means they go on forever and ever and ever and ever. Okay? When I put this in my calculator, say I put root 2 in my calculator, it doesn't look like it goes on forever and ever. It stops, but that's only because the calculator screen is small. It actually goes on forever and ever. It just stops like this, okay? So if we put pi in our calculator, pi is above this times 10 thing, so I have to hit shift, this, then I get pi, push equals, push D for decimal, and we can see that pi is not really 3.14, it's 3.14 blah 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 blah. It's takriban, it's approximately 3.14. So pi is actually an irrational number that goes on forever and ever and ever and ever. And when it goes on forever and ever, if you look at the numbers, there's nothing repeating. There's nothing beautiful about these numbers. They just are random, looks like random numbers going on forever and ever. So that's irrational numbers. Rational numbers are when you have things that repeat. So how do I put 5.3 with this little hat in my calculator? I have to go 5.333333333333333. Keep putting lots of threes because it repeats. So anything that repeats, when I push equals, it turns into a fraction. Okay? So any repeating decimals can be made into a fraction. So let's look at the next one. 5.123, 123, 123, 123, 123. Yep, it turns into a fraction. Then we have terminating decimals. Terminating just means to stop. So we have decimals that stop. 4.25, stop. 10.5, stops. 8.125, these stop. And they can also be made into fractions. Okay? So anything that has repeating decimals or terminates, which means stops, are rational numbers. And what's the real definition of a rational number? A number that can be written as a ratio. Another word for ratio is fraction of two integers. What's an integer? Positive numbers, negative numbers, and 0. So anything that can be made into a fraction, like half or negative half, 98 over 99, 5 over 7. These are all fractions. All of these can be made into fractions or ratios. And so that's what a rational number is. So irrational number is when it goes on forever and ever, which means it does not terminate, non-terminating. Non-terminating means it does not stop. And non-repeating, which means it doesn't have anything that repeats in it. And that makes it a rational number. So a number that can't be written as a ratio of two integers. So all of these decimals can be written as a ratio of two integers or written as a fraction. All of these numbers cannot be written as a ratio of two integers or written as a fraction. So let's look at these. So are the numbers rational or irrational, and why? So let's put in our calculator, square root of 77. That's not pretty. It's like a crazy number. Okay, crazy numbers. Anything that looks crazy is an irrational number. So this is equal to some crazy number. And so it's irrational. Why is it irrational? Because it goes on forever and ever and ever. It does not terminate. What does terminate mean? It means to stop. And it does not have anything pretty in it that repeats, like 1, 2, 1, 2, 1, 2, 1, 2. So it does not repeat. Let's look at 48. Square root of 48. It goes on forever and ever. It doesn't have anything repeating in it. Looks kind of crazy. It's equal to a crazy number, some weird number. So it's an irrational number. Why is it irrational? Because it goes on forever and ever and ever. It does not terminate. What does terminate mean? Stop. It does not stop. And it does not have anything that repeats in it. Okay? So it's an irrational number because it does not terminate, does not stop, and it has nothing in it that repeats. Square root of 121. Oh, just 11. It's a nice number. So this is a rational number. Why is it a rational number? Because it's just 11. It stops. It terminates. Okay, so we can say it's a rational number because yes, it terminates. Okay. Also, we can write it as a fraction. How do we write 11 as a fraction? Just put it over 1. And anything that can be made a fraction or a ratio is a rational number. Let's look at square root of 81. 9. Ooh, that's nice. It's just a nice number. So that's a rational number. Rational. Why is it rational? Because it terminates. That's like, yes, it terminates. Yes, it stops. And I can write it as a fraction, 9 over 1. So anything that can be written as a fraction is a rational number. This is already a decimal, so I don't have to use my calculator, but it stops. It terminates. It doesn't go on forever and ever. So because it stops, it's called a rational number. Why is it a rational number? Because it terminates. It stops. Okay. Next one, square root of 16. It's just 4. That's a nice number. That's pretty. So it's a rational number. Why is it a rational number? Because it stops. It terminates. It stops. Okay, and can I make it a fraction? Yeah, I just put it over 1. Anything that can be made a fraction is a rational number, a ratio of 2 integers. What do these dots mean? It means it goes on forever and ever and ever and ever. Is there anything that repeats here? No. So it goes on forever and ever and ever, and it doesn't repeat. So that's a crazy number. It looks crazy, so it's irrational. Why is it irrational? Because it does not terminate. It does not stop. And it does not have anything that repeats. You have to write all of this down on your paper. I know it's a lot of writing, but you must write it down. It helps your brain remember the word terminate, and it helps you remember repeat. So make sure you're copying this down. Pause the video so you can copy everything down. Ugh, that's a crazy number. It goes on forever and ever, and it doesn't repeat. So that's crazy. So it's irrational. Why is it irrational? Because it does not terminate. It does not stop. It does not repeat. Let's look at the next one. Square root of 2. It goes on forever and ever and ever, and there's nothing pretty about this. If this was a license plate, you could not sell it. Okay? It's an irrational number because it's just crazy. Because it does not terminate, does not stop, and it does not repeat. Now remember, it goes on forever and ever, but it looks like it stops only because the calculator screen is small. That's why it looks like it stops, but it doesn't. It keeps going on forever and ever. Square root of 9. Oh, it's just 3. Oops, that says go to class. Just wait. It says 3. But that's a nice number, so it's rational. And so it stops. So it terminates. It stops. Can you make it a fraction? Sure, 3 over 1. Anything that can be made into a fraction or a ratio of 2 integers is a rational number. Well, this looks like it goes 10, 10, 10, 10, 10, 10. It goes on forever and ever, but there's a repeat. Actually, it goes 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So this is really equal to 0.01 with that hat on it. So we have repeating. So that's a nice number. If you had this as a license plate, you could sell it. So that's a rational number because it's pretty and it has a repeat. So why is it rational? Because it has a repeat. It repeats. Okay. Oh, this goes this looks pretty. 100, 1,000. Oh, it doesn't repeat the same number. Like I can't write it like this. I can't say it repeats 100, 100, 100, 100. So this goes on forever and ever, but it's not repeating. It's not nice, so it's crazy. It's almost pretty. So we say it's irrational. Why is it irrational? Because it goes on forever and ever. It does not terminate, which means stop, and it doesn't repeat. Okay, pi. Now remember, pi is not equal to 3.14. That's takriban, that's approximate. We have to see what is pi equal to. Pi is equal to 3.141592 blah 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 blah. It goes on forever and ever. Okay, so it's a crazy number. It's very useful, but it's a crazy number. So it's irrational. Does it have any repeats? No. So why is it irrational? Because it does not terminate, it does not stop, and it does not repeat. Square root of 110. Oh, it kind of looks pretty. If you had, but there's nothing repeating, and it's going on forever and ever. So it's kind of equal to a crazy number. It almost repeats, or it's irrational, because there's nothing repeating that's nice. Okay, so why is it irrational? Because it does not terminate. Oops, it does not terminate. Sorry, it does not terminate. It does not stop, and it does not repeat. Let's look at 14. Square root of 14. It goes on forever and ever, and it doesn't repeat. So it's equal to a crazy number, so it's irrational. And so it does not terminate, and it does not stop. Terminate means stop, and it does not repeat. Last one. Negative 2/3. Oh, just wait. It's a fraction. So if it's a fraction, it's automatically a rational number. I spelled that funny. Rash. Okay, why is it a rational number? Because it can be written as a fraction of two integers, or a ratio of two integers. But if I wanted to look at it as a decimal, what's 2 divided by 3? But there's a 7 on the end. Does it repeat? Yeah, because really this goes 6, 6, 6, 6, 6, 6, 6, 6, 6. It keeps going, but the calculator screen cuts it, and there's a 6 right here beside it. And when you cut it, 6 is big. It has wasta. And so he tells this 6 to round up to 7. So really there's not a 7 there, it's a 6. Lots of 6's. But when we cut it, we have to round it up. So really, I can write this negative 0.6 with a hat. So it repeats. Okay, so it's rational because it's already a fraction. It's a ratio of two integers. But if you wanted to look at it as a decimal, you can say, it's also rational because it repeats.